So what we're going to do today is divide radical expressions. The first thing that we're going to do is divide simple radical expressions. Now, radical expressions behave the same way as multiplying radical expressions, especially when dealing with the exponents. The first problem that we have is problem A, in which we have the square root of 18x to the fifth over the square root of 2x cubed. Our first step is going to be to combine them together into a single radical. That means that now we're going to have, very simply, the square root of 18x to the fifth over 2x cubed. Our next step is going to be to break them to simplify inside the radical. So that means that we begin with the square root of 9x squared, and we're going to rewrite it as the square root of 9 times the square root of x squared. Once we manage to separate them, we notice that we can easily find the square root of 9, which is 3, and we can find the square root of x squared, which is x. So our solution is 3x. And we're done with this problem. For example B, we're going to do exactly the same thing, with the only difference being that we now have a cube root rather than a square root. Our next step is to simplify inside the radical. So we're going to have, we can begin with the cube root of 162 y to the fifth over 3y squared. And this is going to become, or simplify to, the cube root of 54 y cubed. Once we don't simplify the radicand, the numbers inside the radical, we need to separate the constants from the variables. That means that I'm going to write the cube root of 54 times the cube root of y cubed. Now, the cube root of y cubed should be easy to simplify. It's simply y. However, in order to simplify the cube root of 54, we have to go back and create a factor tree so we can find the prime factors and simplify it that way. So I'm going to create a factor tree using 54 as my initial number here on the corner of my paper. We start with 54 and we're going to break it apart into its prime factors. I usually, if it's an even number, start with 2. Then you get 27 on the other branch. That branch branches off into 3 and 9 and 3 and 3. Once you do the factor tree, I notice that I have a total of 3 3's and 1 2, which means that I can write 54 as 3 to the power of 3 times 2. In our case, that also means that we're going to write the cube root of 54 as the cube root of 3 cubed times 2. And then separate it apart even further, so we only have a base 3 on one radical and a base 2 on the other. I notice that I can cancel this, simplify the cube root of 3 cubed to 3, but the cube root of 2 cannot be simplified. And of course, I still have the y that I found earlier on. Reorganize it, and you should have your answer. 3 times y times the cube root of 2. Now go ahead and try practice problems 6 and 7. See if you're able to simplify those radicals. What we're going to do now is rationalize the denominator of a radical division. Our first step is to use the property of dividing radicals to separate the single radical into two radicals. We began with the cube root of x squared times 5 over 12 y squared z, and it's going to become the cube root of 5x squared over the cube root of 12 y squared z. Now, our next step is to separate the constants and the variables on the denominator. Now, the reason why we're going to do this is because we need to break apart the 12. So, better yet, this step would be better to write it as breaking apart the constant into the prime factors that it has. Now, the prime factors of 12 are 2 squared times 3. So we're going to end up writing the cube root of 5x squared over the cube root of 2 squared times 3 times y squared times z. The next step is to multiply both the top and the bottom by a radical that has a radicand that would make the original denominator into a perfect cube. When you have a perfect cube, it means that the index and the power match, therefore canceling each other. So that means that with the original problem that we have, cube root of 5x squared over the cube root of 2 squared times 3 times 2y squared times z, we need to multiply both the top and the bottom by a cube root with a radicand that makes the original radicand of the denominator into perfect cube roots. All that's saying is that the powers need to match the index of 3. So in order to make 2 squared have a power of 3, we need to multiply it by 2. In order to have 3 have a power of 3, we need to multiply it by 3 squared. In order to have y squared have a power of 3, we need to multiply it by y to the first. And in order to have z have a power of 3, we need to multiply it by z squared. And whatever we do to the top, we have to do to the bottom. So the top gets the same thing. Now let's simplify. First, we're going to simplify the top. So we still have the cube as a radical. Like I said, we're still going to have the cube as a radical on the top. But now we're going to begin multiplying things together. Now, on the top we have 5 times 2, which is 10. times 3 squared, which is 9. So we have 10 times 9, which is 90. Now we know that 90 cannot be broken apart into smaller parts and simplified because the prime factors of 90 are 5, 2, and 3 squared, none of which have a power of 3. Then we're going to have x squared, y, and z squared. Notice that on the bottom, we still have the same multiplication. Now for step number 5, we're going to simplify the denominator as well. And I want you guys to watch very closely what happens to the denominator when we simplify. So let's begin simplifying the denominator. Now, for right now, we still have the cube root. When we multiply 2 squared times 2, you get 2 cubed. Now notice what happens. The power is 3, the index is 3. Hint, hint, they're going to cancel out. Same thing with the 3. You're going to have 2, 3 cubed. Then you're going to have y cubed, and then you're going to have z cubed. Now let's go back and see where I got them from. 2, right here, squared times 2 gives you 2 cubed. 3 times 3 squared gives you 3 cubed. Y squared times y gives you y cubed, and z times z squared gives you z cubed. Now notice what's happening. All the powers on the denominator are powers of 3, which match the index of the radical. Okay, so our last step is to simplify by breaking it apart into individual parts and canceling each other out. So let's see what happens. Alright, the top cannot be simplified any further, so it's going to remain the same. So we have the cube root of 90, x squared, y, z. But on the bottom we're going to have the cube root of 2 cubed times the cube root of 3 cubed times the cube root of y cubed and times the cube root of z cubed. All of those are going to cancel out. Okay, that means 3, 3, 3, 3, 3, 3, 3, 3, all cancel out. And the only thing you're left with really is 2 times 3 times y times z. Once you put it back together and reintroduce it back into the fraction, this is going to be your final answer. The cube root of 90 x squared y z squared over 2 times 3 is 6 y z. And that is going to be your final answer. Now go ahead, look at the practice problems, and see if you're able to mimic this process. Now the process is long, and remember, it's just a matter of playing with numbers. Okay? Separate them, put them back together, separate them again, put it back together, until eventually you reach your goal. Our goal in this case was that we do not want to have a radical in the denominator. So let me write here, no radicals in the denominator. So go ahead and try the practice problems and see how far you get.